You know how you ask an AI questions about your documents? We all do it. But what if the AI could do a whole lot more than just answer? Today, we're diving into a really cool method that turns your AI into a knowledge builder, one that creates a permanent, compounding library of everything you feed it. I mean, really think about this for a second. What if, instead of you having to meticulously build a second brain, your AI could just build one for you? That is the core idea we're going to unpack right now. But first, to really get why this new approach is such a game changer, we have to talk about the big, fundamental problem with how most AI tools work today. Let's call it the AI that forgets. So the standard way things are done is something called Retrieval Augmented Generation, or RAG for short. You give it some files, ask a question, and the AI hunts through them to spit out an answer. But here's the kicker. The very next time you ask a question, it has to do all of that work all over again, completely from scratch. It has zero memory of the last conversation. And this really lays out the difference. On one side, you've got your standard AI, which basically has amnesia after every single question. On the other side, you have this LLM wiki idea, which acts more like an actual brain. It builds knowledge, it learns, and it compounds when it knows over time. You can just feel the frustration in this idea, can't you? Imagine you're a researcher, and you've fed an AI dozens of dense academic papers. With the normal approach, every single time you ask a question, it's as if the AI is seeing those papers for the very first time. That's the bottleneck we're trying to smash through. So if the problem is an AI with amnesia, well, the solution is to give it a permanent memory. And that brings us to the core concept here, building a compounding knowledge base. And this idea comes from a pretty heavy hitter, Andrej Karpathy, a co-founder of OpenAI and the former AI director at Tesla. He calls his solution the LLM Wiki, and it basically flips the entire process on its head. Karpathy just puts it perfectly. He says, the key difference. The wiki is a persistent, compounding artifact. The synthesis already reflects everything you've read. See, it's not about searching the raw files every time. It's about consulting a pre-built, organized summary that's already been created. And Karpathy gives this brilliance analogy to help wrap our heads around the roles here. The AI, it's the programmer, doing all the heavy lifting. A tool like Obsidian is your IDE. It's the interface where you can see all the work. And the wiki itself, that's the code base. It's a living, growing project that's being actively maintained by your AI programmer. Okay, so we get the why. That makes a ton of sense, but how does this thing actually work? Let's break down the architecture. It's actually incredibly simple and elegant. You have just 3 layers. First, your raw sources. These are the original PDFs, articles, you name it. They're read-only. The AI never messes with them. Second, you have the wiki. This is just a folder of markdown files that the AI creates and maintains. And third, the schema, a simple document of rules that you write to tell the AI how you want it to build the wiki. All right, now for the really fun part. Enough talk, let's actually see this thing in action. We're going to watch the wiki grow from absolutely nothing. So to get started, we need to feed the wiki its very first document. I'm going to use a web clipper to save a travel article about Tokyo, and I'm just going to drop it right into that raw folder we talked about. This could just as easily be a PDF you drag and drop from your desktop. Now we fire up our AI coding agent and give it a command. And check out how ridiculously simple this is. I just added a new source to the raw folder. Please read it and update the wiki. That's literally it. And right away, the AI gets to work. It reads the entire document. It pulls out all the key concepts like neighborhoods and landmarks. It spins up brand new wiki pages for each of those things. It updates a central index so it knows what it's made. And this is key. It automatically links all the related ideas together. It's doing all the tedious grunt work that we all hate to do. And boom, this is the result from just that one document. What you're looking at is Obsidian's graph view. Every one of those dots is a page, and every line is a link. We just went from a flat, boring article to a living network of interconnected ideas. But this is just the beginning. Now for the real magic, because this isn't just about summarizing one document at a time. It's about synthesizing knowledge across many documents. Let's see what happens when we start connecting the dots. So now I'm adding a second source. This time it's a guide to Japanese food. And again, I'm just dropping it into the raw folder. And then we give the AI the exact same super simple prompt we used before. No changes. And this is where the system really shows its intelligence.
It doesn't just create a bunch of new separate pages for sushi and ramen. No, it goes back and it updates the existing neighborhood pages with information about restaurants. Then it adds new links connecting the food concepts to the places we already know about. It's actively weaving the new knowledge right into the old stuff.
This right here is that compounding effect in action. You can see it visually. Our graph has more nodes, sure, but more importantly, it has a much higher density of connections. The wiki isn't just bigger, it's genuinely smarter. The relationships between topics are now explicitly mapped out for us. So, because of that, we can now ask a question that would be really hard for a standard RAG system, because the answer requires connecting ideas from two completely separate documents. We'll ask, what neighborhood should I stay in for the best food and major temples? And it delivers a fantastic synthesized answer. But here's the most important part. It's not frantically rereading those raw articles. It is consulting its own pre-built, organized wiki, pulling from the pages on food, temples, and neighborhoods that it already created and linked together. The hard work of synthesis is already done, and it even gives us citations pointing back to the exact wiki pages it used to form the answer. So why does this matter? Well, the applications are just huge. If you're a student, this is a knowledge base that grows as you read research papers. For business, it's essential brain built from all your meeting notes and project documents. For any curious person, it's your own personal encyclopedia, keeping track of everything you learn from books, articles, and podcasts. At the end of the day, this isn't just another tool. It's a system that learns with you. The knowledge compounds over time, becoming more and more valuable with every single document you add. So the real question isn't whether it's useful, it's what personal encyclopedia would you build?
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.